Gas Labs TDS Part 1. This will be the can crushing experiment. I'm going to take an empty Coca-Cola can. Okay, and what I'm going to add, I don't know, it says 25 milliliters of water. I probably have 15 to 20. I'm going to go a little bit less with that. And then what I'm going to do is put that in this can. I'm going to heat it up. My Bunsen burner going. And let's see, I thought I had some matches back here. I think I do. I light this match. Get the burner going. Okay, and we're going to get this heated up. Now, I want to kind of get this pretty hot where it's steaming. And let's just think about it. If I heat this little bit of water in the can, what's going to happen to the water molecules? They should be moving faster, right? And then maybe some of them will convert from a liquid to a gas. Any gas molecules of vapor will move faster the longer I heat it. Now, will there be a pressure change? The lid is still open to the atmosphere. If not, then the molecules would be striking the sides of the container harder and with more force, increasing the pressure. But because it's open to the atmosphere, it is equalized with the atmospheric pressure. And that's why the can isn't either exploding or being pushed in on. The pressure pushing out from the can is the same as the pressure, the air pressure pushing in, because it's all equalized to atmospheric pressure. I'm getting this going pretty quickly, and what I'm going to do is take this and invert this, okay, into this other container. And so this is heating pretty good. I see steam coming out. Maybe I'll just get that a little bit more. And then I'm going to take this and put this into this container right here. I'm going to submerge it enough so that that hole is completely covered and it's sealed off. It's not equalized to the outside pressure. So I'm going to grab this can, take it, and put it here. And kaboom, we get the pop can, not explosion, but implosion. Okay, when I put it into here, it was completely sealed off. Okay, then I'm thinking about, was the pressure greater in the room or pressure greater in the can? Well, what's pushing with more force? The room pressure? Yes, pushing with more force, pushing in than what was pushing out. Did we change the pressure in the room? No. Did we change the pressure in the can? Yes. After it was heated, molecules were moving real fast, but then I put it in here and they cooled down and moved more slowly, striking the sides of the container with less force, causing there to be less pressure in the can relative to outside. And that's what led to the can being smushed in from the outside. I'm going to go to a screen share here, and let's take a look. And let's see. So you have this lab, two labs, TDS. TDS, that stands for that don't suck, because it's not, sucking would be a pulling force, but we're talking about a pushing force, and which pushing force is dominating, and therefore pressure moving from high to low. Okay, these are the instructions, and then you have these questions, and I think we talked about a lot of these things. What happened to the water molecules in the can when it was heated? What happened to the gas molecules? Okay, what happens in the can after it's placed in cold water? So you think about that. And then what happens to the can after it's placed in cold water? Well, we saw that. That was the implosion where it got crushed down. And then explain why this occurs. Why did it implode? Okay, why did it get crushed in? And there's a couple things you want to address. The comparison between the pressure in the can to the room pressure. So what was the pressure inside the can? What was the pressure in the room? Okay, and was one greater than the other? That would be your pressure differential. The effect of the pressure differential was actually the can being crushed in. And what was the cause of the differential? Was it a change in the atmospheric pressure on the outside, or was it a change on the inside pressure? And then what caused that change of pressure on the inside? So that's what you'd want to address there. In the next video, we will look at the egg in the flask. The questions are similar, and actually the concepts behind them are very similar. I won't go through the questions when I do that video, but you will get to see the video and see what happens. So, all right, good luck. And again, you're answering the questions to these things after watching, trying to put it in your words and describing what you're seeing and sharing your understanding of that. All right, thank you for watching.